Okay. I'm going to start with factoring. Taylor wanted another one. I have one or two of these kind of problems. So let me do this one first, and then we'll go into the factoring. Okay. So we're going to simplify these. And we'll get rid of the brackets first, the parentheses first. So on this side, I'm going to distribute the 3 times A and 3 times B. I have 3A plus 3B plus 7. No, not plus 7. Plus all of this stuff. So in here, I'm going to do 21 times A and 21 times B. And I'm going to leave that 7 outside. So 21A minus 21B minus 11. And now I'm going to rewrite it without the brackets. So I have 3A plus 3B plus 7 times 21A, 147 A minus 7 times 21B, so minus 147B minus 7 times 11, $77. So I can combine my A's with my A's, my B's with my B's, and just the number by itself. So with the A's, I have 3A plus 147A. So that's 150A. With the B's, I have 3B minus 147B. That's minus 144B. And I adjust the number, just my constant, I have minus 77. Okay. 3x minus 2 times x minus 3 times 2x minus 3x plus 8. Same thing, I'm just going to start rewriting it and getting rid of the brackets. Here I have 2x minus 3x, so they're the same variable. So I will combine those, and I have minus x. So this is a minus x inside the brackets. Okay. So I'm going to rewrite what is in the brackets before I multiply it by the 2. Because it looks all yucky. X minus 3 minus x plus 8. Now inside the brackets, I'll combine what I can. I have an x minus x. So x take away x is nothing, it's gone. And x's are gone. I have minus 3 plus 8. So minus 3 plus 8 is the same thing as 8 minus 3. So it's 5. So inside this whole bracket, it's just a 5. My rest of the stuff still stays the same. So now I have, 3x minus 10. I did the 2 times 5. And that's it. I'm down to as small as I can go because I don't have any other x's to combine or any other just numbers, any other constants. Let me just do one more. So I have 1/8 times 16x plus 8 minus 17 equals minus 1/4 times 8x minus 16. To get rid of the fraction, I'm going to multiply by a number that 8 can go into and 4 can go into. What's that number going to be? A number that 8 is divisible into and 4 is divisible into. Good job, 8. I'm going to multiply the whole thing by 8 over 1. So 8 times 8 is 8 over 8. That's just going to be 1, so I'm just going to cross it out. And I'm just going to be left with the 16x plus 8. I'm only multiplying the things that are outside of the brackets. Because in the brackets, it's like a protective force field. So 8 times 17, 80, 136 minus 136 equals 8 times 1 is 8. 1 times 4 is 4. Keeps this. Okay. So the next time I'm going to bring these out of the brackets because there's nothing I can do to them inside because they're not the same value. They're not the same x variable or constant. I can't simplify it anymore. So I'm just going to bring them out into the world. 16x plus 8 minus 136 equals 4. We're going to 8 twice, so minus 2 times 8x minus 16. On this side, I'll combine 8 minus 136. So 136 minus 8. And I keep the negative sign. Minus 128. So I have 16x minus 128 equals minus 16x. Negative 2 times negative 16 is positive 32. Now when I get all my x's, I like to get all my x's on the left side. So I'm going to move over this minus 16x and he becomes a plus 16x. The 16x plus 16x is 32x minus 128 equals 32. And sorry, since I've decided to keep the x's on the left side, I'll put the constants, just the numbers, on the right side. So plus 128. Oh, man. Oh. $128 plus 32 is 160. So 32x equals 160. I will divide both sides by 32. And I end up with x equals 160 over 32. And we'll just, since they're both even, or you could divide by 16. But since they're both even, I'll just do half and half and half until I can't go anymore. So half of 160 is 80. Half of 32 is 16. And then I'll go again. Half of 80 is 40. Half of 16 is 8. Half of 40 is 20. Half of 8 is 4. Or we could have done 8 into 40 was 5 times. But 4 will go into 20 5 times. So my x equals 5. And on the test, I do have 2 of these, which is just solve for x by reducing the expression in the equation. Okay. We go to factoring. Okay, there's a thing called the zero product rule, which is the basis for all of the factorings that you do. Okay. The zero product rule says that if the product of several factors is zero, then one of them has to be zero. One of the factors have to be zero. So we'll just do solve for x, just like we did in the last one, where we shrunk it down and we set them equal to x, equal to whatever the other side was. It's the same thing with these. I will start with one thing, and this is product, so that means I'm multiplying, right? X minus 5 times x minus 3 equals 0. So the zero product rule says that if the product of several factors, so if I multiply this factor times this factor, and I got 0, then one of them have to be 0. So using that, I'm going to set them both to 0 and keep that answer. I'll do the left side. X minus 5 equals 0. And I'll do the right side. X minus 3 equals 0. So I still need to get x by itself. I move over the 3. And x equals 3. But I have two answers, and I'll show you how you know you have two answers. So first, because I have two factors, I have two like sets of parentheses. And that's how I know I'll have two answers. X minus 5, I'll take the 5 to the other side. And x equals 5. So x equals 5 and x equals 3. Now, if we were to multiply this out, remember the chubby cross-eyed kid? This is a binomial, so I have two terms times a binomial. And I'm going to end up with a trinomial. This is going to be an invisible 1 for the exponent. Anytime you don't have anything, it's an invisible 1 exponent. So I make sure that I multiply x times x. And I'll keep that over here as x squared. Multiply minus 5 times minus 3, which is plus 15. And then I'll work on his chin and his smile, which is the middles. So minus 5 times x is minus 5x. And x times minus 3 is minus 3x. And those are all of these terms multiplied by all of these terms. And now I'm going to combine my like terms. I only have one x squared term. We like to keep the whole number at the end. And I can combine my x terms since they're both x's. So minus 5x, taking away another 3x. So I'm getting more negative. I'm adding negative numbers. So I have minus 8x. And if I were to plug in 5 into this equation, it would equal 0. And if I plug in x into this equation, it would also equal 0. So factoring is taking this and making it look like the x minus 5, x minus 3. You set them all to 0 at the end when you're solving. Okay. So I have 3x minus 1 times 5x plus 4 times x plus 1. So I don't always have to have just two things. I could have 3 terms, 3 binomials equals 0. Because it says equals 0, that's how I know I can set each of these brackets equal to 0, because it's equal to 0. So I'll start with the first one, 3x minus 1. I'll set it equal to 0 and solve for that. 1 to the other side. 3x equals 1. Divide both sides by 3. X equals 1/3. Set the next one also equal to 0. 5x plus 4 equals 0. Minus 4 on both sides. X equals negative 4. Divide by 5 both sides. X equals negative 4/5. And I said the last factor equal to 0. X plus 1 equals 0. And just 1 on both sides. X equals negative 1. So I can plug in 1/3 for all of these, and it's still going to be equal to 0. I can plug in 4/5 into all of these x's, it's still going to be equal to 0. And I can plug in negative 1 to all of these, and it'll still be equal to 0, because each one that I plug in, when I plug in the red ones, it's going to make this whole thing 0. Times anything else, doesn't matter what it is, it's going to be 0. Same thing for the green one. It's going to make this term 0, which when it's multiplied by other two terms, is still going to be 0. What's this one? Is a little. So you can have 1 factor, you can have 2 factors, you can have 3 factors, you can have as many factors. I don't think we do more than 3, so in this class. These are 2 factors, right? Because this 4 is a factor, and this x minus 6 is another factor. But you're only going to have one answer for x because the 4 doesn't have a variable next to it. So when you set it this equal to 0, you end up with 4 equals 0, which makes no sense. So that doesn't count. And then you're going to set the other one equal to 0. X minus 6 equals 0. Add 6 to both sides. And x equals 6. You're going to have one answer because I only have, because I have one variable to the first degree. When we had the other ones, let's see. Why doesn't it let me show you the previous screen? Anyway, I can't, it doesn't let me show you the previous screen, but the one where we had x squared minus 8x plus 15. I'm gonna have two answers because I have my variable is to the second degree. So this little number also tells you how many answers for x you'll have. Okay, so let's do this one and see if we're factoring this binomial. I have two brackets. Usually you will end up factoring a trinomial, 3 terms, into 2 smaller binomials. So for the x part, I'm looking at, this is x squared, so I need this number, the first part of this bracket and the first part of this bracket to multiply and give me x squared. And this is my x times x gives me x squared. Then I look at the last number, 15, and I try to think, what times what gives me 15? There's not many choices.
5 and 3.
5 and 3, right? I could try 15 and 1, but it's the cheap solution, and usually it's not that. 5 times 3, so I'll do 5 and 3. And now you need to look at your signs. Everything's a process. Since this is a plus, right? My second sign or the last sign in the expression is a plus. I need 2 things to multiply to get it to be a plus. So either I'm going to have a plus times a plus or a negative times a negative, because that is also gives me a positive. So while I keep that in mind, I'm looking at the first sign, and I know that I need them to add up to give me a -8. So do I want to go with a plus and a plus and hope that somehow it adds up to -8? Or do I want to go with a minus and a minus? I want to go with the minus and the minus so that when I add my middle terms, it gives me a negative number. So I'm here with x times x. This is me checking the work. X times x, x squared. -3 times -5, positive 15. So far, we're good. The thing that gives us the problems is the middle term. So now I'll check the middle term. -3 times x is -3x. And x times -5 is -5x. So my middles will add up, because I'm adding these, to -8x, which means this is the answer. Because when I fix this, I keep my first term as the variable squared. The last term, I want to have just a constant, just the number part. And the middle, I want to have my -8x. Okay, so now we're just gonna. You have any questions so far? I'm trying to get really slow. I really like factoring. It's really, really important that you pick up the patterns and how this stuff happens. Because from here, for every other math class, it's just about patterns. Geometry, algebra 2, calculus, it's the same stuff with just more of it. but patterns are really important. Okay, so I want to factor 50 y cubed minus 100 y squared minus 50 y. I want to factor. I don't want to get any y equals any business. I just want to factor it. Why am I being atrocious today? Okay, so I have each of these terms have two parts. There's the number part, the 50, the number part, the 100, the number part, the 50. And then there's the variable part, y cubed, y squared, just y. So I'm going to set it up like this. I have three terms. I'll make it big enough, and I'm going to have something on the outside, something that I can like vacuum out of each of those terms, something that's shared with each of these terms. I like to start with the letters. It's easier for me, but if it's not for you, that's fine too. You'll get the same answer. This has one y. This has two y's because it's y squared. And this term has three y's. So how many y's do they all have in common? One. They have one y in common because he doesn't have one y, he has two. He only has one. So I can't say that they have two in common because this guy only has one y. So I'm going to take out, I know I'm definitely going to take out a y. And what about the number part? What number do they both, all of them have in common? What number can I divide into all of them nicely without a remainder?
80.
80? What?
50.
50, yes, thank you, 50. So I kind of vacuum out a 50y out of each of these terms. I'm going to pretend to like divide this 50y. 50 will go into 51 time. 1y will go into the 3 y's, and I'll have 2 y's left over. I have a y squared. Minus 50 will go into 100 twice. This 1y will go into this 2 y's, and I'll have 1 y left over. The last term, 50, will go into 50 one time, a minus 1. And this y will go with this y, and nothing's going to be there. So I'll rewrite this without the funky looking y, I mean 1 in front, because that's just for us to work it. So the factors of this expression will be 50y times y squared minus 2y minus 1. Right? Yes. Okay. Let's do another one. Get in the habit of boxing your answers, so it's going to be a lot of paper, so a lot of screen or whatever. (18a to the 5th). Okay, 18 a to the 5th minus 12a cubed minus 16a squared. My three terms, they all have a's and they all have even numbers. So I'll look at them and see what can I extract, what can I vacuum out of them. This one has 5 a's, this has 3 a's, this has 2 a's. If it helps you to write them, feel free. Hopefully you figure out and you not have to write in 12 a's, because it's gonna take up time. Okay, the number part, I have 18, 12, and 16. So I'll try to think of a number that can go into all of them nicely without any leftovers.
Would it just be 2?
It'll just be 2, right? Because at first I'm thinking 6, but 6 would work for this one, and the 12, but not for the 8, not for the 16. And then I said maybe 4, but 4 worked for the last 2, but not the first one. So they're all even. You just take a 2 out. And then we look at the a's, right? This one has 5 a's, 3 a's, and 2 a's. So how many a's do they have in common that they share? They each have the same amount of a's.
2.
2. So I'm gonna take out 2 a's, which I write as a squared. So it's kind of like you take the biggest number they have in common and the smallest amount of variables they have in common. So 2a squared, I'll do the 2 into 18, we'll go 9. And this has 2 a's, a squared divided into a to the 5th leaves me with 3 a's, or a cubed. Okay, side note, there's a rule when you divide exponents, that you subtract the exponents. So if, sorry, a to the 5th is what we had, a to the 5th divided by a squared. I'm going to keep my base, my big number of a, and do 5 minus 2, and get 3, a cubed. So the next one, 2 will go into 12 6 times. And a squared divided into a cubed leaves me with 1a. 2 will go into negative 16, negative 8 times. And a squared into a squared equals a to the 0. And anything to the 0 power equals 1. I can have 14 to the 0 power equals 1. I could have 1,743 to the 0 power equals 1. I have a to the 0 power, it equals 1. So that's 8 times 1, which is just going to leave me with the 8. So 2a squared times 9a cubed minus 6a minus 8. Oh, Lord. Questions so far?
No questions.
Alrighty. Okay, 12 a to the fourth b cubed minus 16 a cubed b cubed minus 4 a squared b plus 8 a squared b squared. Make my bracket really long. And what can we vacuum out? A 4. Okay, yes, a 4. Take the 4. And what about our letters? How many A's do they all have? All of these terms have in common? 2. Yes, because this one has 2. This one has 2. This one has 3. This one has 4. Okay, so I'll take out 2 A's. 4A squared. What about the B's? It's 3.
Would it just be 1?
Yes, just 1, because this B is only 1 there. He doesn't have any other exponents, so it's 4A squared B is what we can vacuum out, kind of. What we can extract, and then we'll divide this term into this one, this one, this one, and this one, and put the leftovers here. So 4A squared B, this is like doing 4 little problems together. So I'm gonna divide 12A to the 4th. It may be easier to see it like this. Into 4A squared B, that's my first problem. That's this part here. So I have 3, how many A's do I have? 4 minus
Just
2, right? So 3A squared. And I have 2 B's left over. And then my next problem is the 16A cubed B cubed divided by 3. No, so what am I doing? That's not the right one. 4A squared B. So I divide this into that, I have a minus 4
minus 4A, just A and then B square.
B squared. Yep, good job. And then my next little problem is 4a squared b divided by 4a squared b. So what's that gonna be? Wait, 4, this is the same exact thing, right? So anything over itself is 1. So this is a minus 1. And we do the last part, which is 8a squared b squared over 4a squared b. I have 0.82. Sorry. A squared is gone. And I have a b left over. Bring this a little closer. I can erase that and erase. No, I can't. Just gonna bring it closer. So my answer is 4a squared b times 3a squared b squared minus 4ab squared minus 1 plus 2b. Does that make sense? Okay. This one's a little different, but it's still about seeing the patterns. So it's 2x times x minus y times x minus 1. Now this is one term. This is still a binomial, believe it or not. It's just 2 terms. This is all one term. And this is all one term. What, if anything, do these 2 terms have in common? What do they have in common? In the first term, the 2x is multiplied by x minus 1. In the second term, the y is also multiplied by x minus 1. So that's what they have in common. They both have been multiplied by x minus y. So I'm going to take out the x minus y. And since it's 2 terms that I'm taking out, I put a bracket around the whole thing. So I'm going to divide this x minus y into this whole term, which I have x minus y and x minus y in common. I'm left with the 2x. And the other one, I'm dividing x minus y into this whole term. I have the x minus y in common, so those will cancel, and I'm left with a minus y. So that's my answer. The answer is x minus y times 2x minus y. How's that one? That one's like factor by grouping. Do another one like that. Okay, 4 times a plus b, that quantity squared, minus 9 times a plus b. This is still a binomial because it's 2 terms. This is all 1 term. And this is the other term. There's still 2 terms, so binomial. What do these terms have in common? What do they both share, if anything?
A plus B.
A plus b. So I'm going to factor out an a plus b. And since I factored out more than 1 term, I'm going to put brackets around them. I can keep them together. This a plus b divided, if you will, into this term leaves me an a plus b, and I'm left with an extra a plus b because I had 2 here. I had 2 a plus b's. And I have this 4. And before I write them down, the a plus b for the other one, a plus b into this, a plus b, leaves me with the 9, the minus 9. So I have 4 times a plus b minus 9. And then I'm going to clean it up a little bit. I'm going to try to make the answer as clean as I can be. So a plus b times 4 times a times b and minus 9. I'm going to clean this up because I don't want to have this minus 9 out here just like that. I could put him in with this factor. So a plus b times 4a plus 4b minus 9, and then close the bracket. You could also leave it like this, it's your choice, but. Okay. So any one of these would be the answer, honestly. This one or this one. Or even this one, because this is already in factored form. Okay. Five times x plus y squared plus 6 times x plus y. This is a binomial, but I have two terms. I have my 5 times x plus y squared and my 6 times x plus y. What do they have in common?
X plus y.
X plus y. There's x plus y here, and there's x plus y here. So I'm going to factor out an x plus y. And since I factored out those two terms, I'll keep them in brackets so they know they're together. X plus y divided into 5 times x plus y squared leaves me with the 5. Okay. 5 times 1 x plus y, because this one says I have x plus y squared. I have two sets of x plus y. So it leaves me with another x plus y out here. And the next term, I take my x plus y into this whole term. And I'm left with just the 6. So I'll clean it up a little bit. I have x plus y. Five times x. 5 times y. And plus 6. How is this one different than the other ones we've been doing? X squared minus 4x equals 0. How's it different? I can still factor them, but this one has an equal 0 in it. So this means it wants me to find an answer. X equals blah, blah, blah. Since it's a 0 product rule, I've multiplied some stuff. It equals 0. That means one of them has to be equal to 0, which means I'm going to factor it and I'm going to set each of those parentheses equal to 0. So what do these two terms have in common? X squared and 4x.
Would it just be 1?
It would just be one, the number 1. And what about the x part? How many x's do they have in common?
One.
Yep, just one x. So x divided into x squared leaves me with an x. X divided into 4x leaves me with the 4 minus 4. I set both factors equal to 0. Have x equals 0 and x minus 4 equals 0. And I have two answers because I have the square root, my highest variable squared in that equation is a 2. So I'm going to have two answers. I have x equals 0 and x equals 4. You guys want to take a break and we come back and we'll start to do nothing but binomials and trinomials. Yeah?
Yeah.
All right, and give me a 5-minute break. A lot of these 3-term things, trinomials, okay? We'll start with this. Don't be upset if you don't get it right away, because it takes a million years of practice to see how it works. Okay. X squared plus 6x plus 5. When you see that there's 3 terms, usually it'll be broken down into 2 smaller binomials. You're gonna look at the first term. First of all, before you try to factor it, you verify that the first term is an even exponent. Okay, a 2, a 4, a 6, a 22. Hope not to do that to you, but a 22. And that the second term is half of the exponents of the first term. So this has x squared, so 2x's, and this only has 1x. Last term, just a constant. Or it could also be something else squared. Or even. So I'll look at the first term and I'll say x times x gives me x squared. That's my first term. The last term, what times what gives me 5?
1 times 5.
1 times 5. This is a plus here, right? My second sign is a plus. So I know I either need 2 pluses, both of those terms have to be positive, or both of those terms have to be negative. While I'm thinking about this, I'm looking at this sign and saying, well, I need them both to be positive, because when I add them up, I need them to be positive. So which set of signs am I going to go with? The positive ones, because I need these, when I add them up, my middles to be positive 6x. So I'll check this. I know x times x gives me x squared, I'm good there. 1 times 5 is 5, I'm good here. The only thing that ever really gives me issues is the middle. So 1 times x is x. And x times 5 is 5x. Positive. Positive. Gives me positive 6x. So I'm good there, which means this is my answer. This is my factored answer. X squared plus 8x plus 7. Break it down into 2 smaller binomials. First term is x squared. My second term is half of the exponents I have in the first one, so I'm good. X times x gives me x squared. What times what gives me 7? Seven times 1. 7 times 1 gives me 7. And I look at my second sign, which is positive. So I either need a negative times a negative to give me a positive, or a positive times a positive to give me a positive. My first sign is positive, so I'm gonna need to go with the positive ones because that's what's gonna add up to positive number. So x times x, I'm good with the x squared. 7 times 1, I'm good with the 7. I just check my middles to make sure. 1 times x times 7. Together is 8x. I'm good. Hmm. Five x squared plus 12x plus 4. So this, the difference between this problem and the others is that what we call a leading coefficient. This first term doesn't have anything in front of it. It's just a regular old 1x squared. This is a regular old 1x squared. Now you have 5x squared. So this is going to change, meaning that sometimes you'll have to flip the numbers so that the order still works. But your exponent is squared. The second term is half of that exponent, so you're good. We'll check. The first term, what times what gives me 5x squared?
Would it just be 1?
Yes, just 1 times 5, right? So I have 1x and 5x. And I look at my last term. What times what gives me 4?
Two times 2.
I can do 2 times 2. But I'm also going to write 4 times 1 over here because that's another option. And the other ones I didn't have any choice before. But maybe if 2 times 2 doesn't work for us, maybe 4 times 1 will work. I look at my last sign. And so my last sign is positive, so I'll either need 2 negatives to give me the positive or 2 positives. But I really need them to add up to be a positive, so I'm going to go with this one, the positives. And now I'm going to check them all again. X times 5x, 5x squared. 2 times 2, 4. And I'm going to check my middles because that's likely where I would have a problem. 2 times 5x is 10x. And 2 times x is 2x. Gives me 12x. So I'm good there too. Now, if someone were to choose, let's say someone chose 4 times 1. And they had x plus 4 and x plus 1, probably 5x. Maybe they did it this way. But they still have 5x times x gives them 5x squared. 4 times 1 gives them the 4. And now let's check the middles. I would have 4x and 5x. And that's 9x in the middle. Not the same thing, but the factors look like they work. That's why you have to check back your answer. Let's five. 6x squared minus 17x plus 12. Okay, again, I have a leading coefficient that is not 1, so I might have to flip around some things. Yeah, look at my last. I can do it. My last sign is positive, so I'll need a negative times a negative or a positive times a positive. My first sign is negative, so I'm gonna choose the two negative numbers. So it can give me a negative when I add them together. Some people like to fill in the signs first. Okay, what times what gives me 6x squared? Or if you want to think about it, what times what gives me 6?
3 and 2.
3 times 2. So 3x times 2x. I'm also going to write here 6x times x, because just in case these don't work, I want to be ready to go with my sub. See if I can substitute in and keep it moving. And what times will it give me 12?
Six times 2.
Thank you, 6 times 2. So I'll put 6 times 2. I'll also put 4 times 3, just in case. And also put 12 times 1 out here just in case. And I'm gonna check my middles. I'll check everything because 3x times 2x, yes, 6x squared. 6 times 2, negative 6 times negative 2, positive 12. Now check my middles. 6 times 2x is 12x. Minus 12x. 3x times minus 2 is minus 6x. What's my middle term? My middle term according to this is minus 18x. So close. So now I have to figure out what I can switch out to still make it work. Usually I try to flip the second numbers to see if that has anything to do with it. I'll try that first. And if that doesn't work, then I'll try different numbers altogether. So I'll try, instead of, what do I have, 6 and 2, I'll put 2 and 6. And I just have to check my middles again because my first number is going to be the same and my second product is going to be the same. So I'll check my middles. This is minus 4x and minus 18x. So that's too big. All right, that gives me a minus 22x. I'm not going to use those. Can I use another set of numbers from over here? Maybe 4 and 3 or 12 and 1. So I'll try 4 and 3. So I keep them on the side. I'm going to try 4 and 3. in this order. I just randomly pick 4 and 3 and see what happens. Okay, my first product's still gonna be the same, so I didn't even change those. I know that 4 and 3 is 12, so I'm good there. Now I'm gonna check my middles. Minus 4 times 2x is minus 8x. 3x times negative 3 is negative 9x. Negative 9x plus negative 8x is negative 17x. So that's the one we needed. So it's 3x minus 4 times 2x minus 3. Oh, sorry. Okay. Do another one. Let's see. Twenty-five x squared minus 20x squared plus 4. Let's start with my okay, to get 25x squared, I can do 5 times 5. I could do 25 times 1. To get my 4, I could do 4 times 1. Or I could do 2 times 2. So I'll try 5x and 5x for this one. And for the 4, I'll try 4 and 1. My last sign is positive, so I'll either need 2 negatives or 2 positives. But my middle sign is negative. So I want to go with the 2 negative signs. The first one is good. My second one is good. And I check my middles because that's where I'm more likely to have problems. So minus 20x and minus 5x. That gives me minus 25x. So that's too big. I can, if I switch them around, I'm still going to get the same numbers because I have a 5 and a 5 here. So I don't need to switch them. I will put in 2 times 2 instead of the 4 times 1. So I'll put in 2 times 2 instead of the 4 times 1. So my first term, last term will be all good. Negative 2 times 5x is negative 10x. And negative 2 times 5x is negative 10x still. Those two together, negative 20x. And that's what I have. So this is my answer. But since if you notice they are the same exact thing, 5x minus 2 times 5x minus 2, the simplified form. And I know web design takes off for this. Is to write the same terms squared. Okay. I'm gonna let you write, I'm gonna check, I'll check this evening, I have another class, I'll check this evening to see what, if I posted the meeting, the review for the second test. And then I'm gonna probably give you like 50 of these just to do. Because it's really important just to get in the habit of doing them. You could find,